Hello, my name's John, and I'm here to help you understand physics. Now, before you go hit one of the videos over to the side, let me explain to you what makes heroic physics different from your average physics education video. Here at Heroic Physics, we use superheroes and the occasional science fiction reference to help you understand physics. Now,
without further ado, let's learn some physics.
You're late.
Well, hey, I mean, there was a train, can't really... I guess I could run around them, but I didn't, so...
Time for the intro. Often in physics classes, the first subject discussed is velocity and acceleration. Well, what is velocity and what is acceleration?
You think I'd know, but I don't.
They are not the same thing. Today, we have the Flash here to help us learn.
Hello, everybody. I took some time out of my busy day today. There's probably people I could be saving, but whatever, It's in my contract that I get a few free days, so I guess some people are just gonna have... No, you know what? We don't need to go there. We're gonna learn about some physics today, and it's gonna be great.
Physics is great. So...
Said by the Flash.
Yes, said by the Flash. So, now we are going to learn some one-dimensional kinematics. Let's get the move on it. In physics, to fully understand motion, you need to know three key concepts: position, velocity, and acceleration. Most of which I mentioned was position, which is where you are, space. To measure your position, we need to know a point where it originates. To start off the trail right here, we'll go call the origin. If you're at the origin, your distance is 0. Now, what does that mean?
Nothing.
Exactly. It means nothing. It's at it. We're not away from it. We're not close to it. We are at it. We're 0. Now, 0 what? Means 0 anything. 0 miles, 0 feet, 0 meters, 0 parsecs, 0 light years. We need to specify what our unit of distance is so we can figure out how far we are when we actually are away. Flash, would you mind zooming off to get the meter stick? Thank you. So this here is a meter stick. What does that mean? It means it's a meter long.
You can't just ask me to go get things for you, okay? That's not cool. Continue with your thing, but next time, just give me a heads up. Go ahead.
Physics, we use the metric system to measure stuff.
I like football, so yards are cool. Why don't we just do it in yards?
Because basically only America uses the English system nowadays, while the international system of the metric system is used worldwide. Now that we have established what distance and position is, we're going to put it into practice. So, we could have the Flash move about 3 meters to your left. Okay, and now the Flash is 3 meters away. Now he can go to my right. 2 meters.
Hey, you see how fast I just did that? Pretty fast,
It just me or did the weather change?
Yeah, funny story about that. So, recently I had a little clash with my buddy the weather wizard. Guess you can consider it a loss on my part because the weather got nice and the snow melted. But I think I did us a favor by losing that one, so... Even if it's a loss, it's still a win.
Now we've had the Flash to your left and your right. We know the distance from both directions, but when you say the Flash is 3 meters away versus when the Flash was 2 meters away, how do we know which direction? It goes back to my right or left for both. Because of this, we need to specify the direction. To do that, we normally standardize in physics as the right side to be the positive side, while your left side to be the negative side.
Wait a second. So, here's the thing. I love the negative. The negative side is my favorite side, and if I'm getting this right, what you just said is, I'm on the positive.
Yes, you're on the positive side.
I love the negative. It's my favorite side. So can we just make this side the negative?
We could. It's completely arbitrary which side you assigned as positive versus negative. For all purposes in heroic physics, we need to standardize the sides. So in all future videos, this side will be the positive side, while your left side will be the negative side.
Okay, but can I go to the negative?
Yeah. What if the Flash wanted to change his distance over a period of time? This is called the speed.
I'm super fast. I know all about speed.
So if we wanted to talk about a change of distance over time, we're actually talking about his speed, which we can see as the Flash runs this way. As the Flash runs this way.
Oh, I have a feeling you're asking me to run that way.
Yes, I am.
Haven't I run enough for you today?
And would Superman be complaining about helping people understand physics if I was to ask him to run that way?
If you want my honest opinion, Superman can't complain about anything. He's an A-OK Boy Scout, here for his honor badge. No, I don't care about Superman, him and his tight tights and his cape, and he'd probably fly over there because it's too hard for him to run.
So you want to prove to the world you're faster than Superman right now?
I guess so, but if I could just say something really quick.
Yes.
Lightning McQueen stole my line in Cars. I am speed.
So the Flash is running at 200 meters per second now, which means he's going at a distance of 200 meters in every second. So his change of distance is 200, his time is 1 second, his speed is 200 meters per second. Now that we know his speed is 200 meters per second, we can specify the units of speed as being meters per second, because speed is change of distance measured in meters over time, seconds, and units of speed in 200 meters per second. Have a nice one.
I had a fantastic run all around the world.
You just went at an astonishing speed of 200 meters per second.
Give or take, 20,000, yeah.
In that direction. Could you run 200 meters per second the other direction, though?
In the negative direction?
Yes.
You know I can.
So the Flash is now running at the same speed in the negative direction. So his speed will be 200 meters, a change of distance, over 1 second. So his speed is 200 meters per second. But now we need to specify which direction his speed is at. But just as we needed to define the positive and negative direction for position, we need to do the same thing for your change of position, aka speed. When we do that to speed, speed is no longer just a speed. It's something we call a velocity.
Hey, how's it going?
That was fast.
Well, obviously. The Flash and everything.
We're just talking about changing position.
Oh, okay, I do a lot of changing in position. It's part of the requirements for my job, you see.
Speed and velocity are two different things, and we use one of them to measure the direction you're going. So speed is just
How fast you're going, right?
Yes.
Okay.
Speed is the measure of how fast you're going. While velocity is just
how faster you're going.
Well, actually, no.
What?
Speed and velocity both measure how fast
you're going. Hey.
Yes, they are. But your velocity doesn't tell you how much faster you're going.
Oh, really?
Really, it tells you which direction you're going.
You'd think they would teach you this kind of thing in Flash school. They don't.
Speed and velocity, they'll have the same absolute value. He was running at a speed of 200 meters per second that way, as well as when he was running 200 meters per second this way.
In the negative direction.
Which brings me to my next point. When he's running to your left, his speed is in the left lower direction. So we're going to call that a negative velocity because his direction is in the negative.
I am okay with that.
Direction. So when the Flash was running to your left, his velocity is negative 200 meters per second. To the right was a positive 200 meters per second. His speed was the same in both cases. To distinguish which way he was going, we used velocity. A positive velocity is to the right, and negative velocity is to the left. Even though speed and velocity are not the exact same thing, as velocity tells you the direction you're going and speed does not, we can still calculate them the same way. We will use the equation speed equals distance over time, or velocity equals distance over time, which can be written as v equals d over time. Can you please stop for one flash?
Oh, I was just having a lot of fun playing with the snow. Wait, do you really need me to run?
Yes, I need to see you speed up.
Can I play with the snow when I come back?
Yes. Okay, so get ready to run right now.
Oh, don't tell me how to run.
So, when the Flats turned around to come back, he had to slow down and then speed back up. He was changing his speed. This change of speed is called acceleration. Acceleration is your change of speed over time. Flash was running. He had to pick up speed. He started with 0 meters per second speed because he wasn't changing his direction. But then he started running and he got
Really fast.
yes, really fast. So he went from 0 meters per second, gained speed until he reached his maximum speed for that jolt. 500 meters per second.
Faster than that, but we'll go with that for now.
So he gained speed, and now this way is the Flash's favorite way to run. So he was
Negative.
going negatively. So he was gaining speed in the negative direction. So his gain of speed was from 0 meters per second to a negative 500 meters per second. So he gained negative 500 meters per second in 1 second. So his acceleration was a negative 500 meters per second over 1 second, or negative 500 meters per second, or negative 500 meters per second squared. Now, when he was turning around to come back to us in the positive direction, he had to slow down. So he went from negative 500 meters per second to 0 meters per second. So his acceleration then was a positive 500 meters per second squared, because we had to add 500 meters per second to his negative 500 meters per second to get him to 0 meters per second.
So basically, I had to lose 500 meters to gain it back on the return trip, to get back
You-
to 0.
Had to lose 500 meters per second in the negative direction.
And then gained it back when I turned around.
Yes, and then back positively.
So I can get back to the origin.
Yes, which is all the way over there. So now that we're back, that's all there is to a basic understanding of 1D motion.
Wait, that's all there is to motion?
The basics.
Oh well, I'm out of here, I guess. See ya.
But wait, Flash, there's so much more we could cover.
There is?
Yes, 2D motion.
Well. No, really, too many people are getting, like, injured over there. I need to go dash off and save them. Like, it was really fun doing the physics today, but, I mean, honestly, it's a total chaos over here. Is it cool if I leave?
Yeah, go beat the weather wizard.
Where do I get my parking validated?
You drove
Yeah, I drove here. Whoa, was I supposed to run here?
Yeah.
That's a little strenuous on the ankles, don't you think? I'll just ask somebody later. I'll see you.
Guess we're gonna get a different superhero for 2D motion. Well, today we learned several things. We learned that position is where you are in space, and we measure your position and your distance in meters. That speed is your change in position or distance over time, and the units for speed are meters per second. That velocity is your speed and the direction you're going in. So velocity can be positive or negative, still measuring meters per second. And we learned that your acceleration is the change of your speed all your velocity over time, which gives us the unit for speed and velocity, meters per second, over the unit for time, seconds, which means the units for acceleration are meters per second, or meters per second squared. Now come back next week to learn about projectiles and two-dimensional kinematics. Same physics channel, same physics time, with a different super physics guest star.